So here are some pointers to graphically represent at solving inequalities in two type of variables. Yeah, these are some pointers in graphical representation when solving inequalities in two variables. Number one, solution region is a region containing all solutions of the inequality. Then, number two, to identify the half plane presented by the inequality, you can take a point AB which does not lie on the line and check if it satisfies the inequalities. If it does, then the inequality represents the half plane containing the points you. Then, if it does, then the inequality represents the half plane containing the point, and you can shade the region. If it doesn't have, if it doesn't, then the half plane that does not contain the point should be shaded. For conveniences, you can take the point 0, 0, that is x and y, to check if it satisfies what the inequality. Number 3, if the inequality is of the type ax plus by greater than or equal to c, or ax plus by is less than or equal to c, then include the point on the line ax plus by is equal to c in the line solution region. To do so, draw a dark line on the line presenting ax plus by is equal to c. Number 4, if inequality is of the type ax plus by is greater than c, or ax plus by is less than c, then don't include the point on the line ax plus by equals to c in the solution region. Draw a broken line / dotted lines in this case. That's what you're going to do here. If it does not, if it's represented in this form, there's no need using a dark line. If I use a dotted line, when I say dotted line, it's kind of lines. That is a dotted line. Lines like this. They're so called broken lines. Lines dash like that. What kind of lines we will use? So now we have an example. Example 1, solve the following inequalities: 40x plus 20y is less than or equals to 120. You see, this when it comes to this particular one, the solving is actually different. It's more complicated in a way. It's somewhat different. It's more complex. So, but it's easier, if you get the whole gist. It's more easier, but it's more complex. But I'm happy for you. You're not doing this math again. I just hope the class don't just stop here. Maybe I'll take up your math 154. I'm doing it for you. Also, if you let me, I know you don't watch all these videos, because that's just like a waste. But all the same, no hard feelings. Let me just proceed. Number 1, where x and y are whole numbers, not fraction, not negative numbers. Whole numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9. That's whole numbers from 0 to 9. Then fractions 1/2, 3/4, all those stuff. Negative number is -1, -2. And they said where x are whole numbers, they are not fractions, they are not negative numbers, they are just majorly whole numbers. So solution: to solve this, let's start with substituting x equals to 0 in the left hand side of the inequality. Therefore, we get 40x plus 20y is equal to 0. So now, I know you get confused here. equals to what? 0. So now it never equals to 0 itself. Wait, let me write it down. So this is what it means. When we added 0, when we swapped in 0 for x entered 40 times 0 is 0. This is 0 here. 20y came down equals to 120. So now, hence, we have what? 20y is less than what? 120. So we divide both sides by what? 20. So our y is less than what? Is less than 6. So for x, is it x our whole numbers? For x1, if x is equals to 1, solution will be 0, 1, 1, 1, 1, 2, 1, 3, and 1, 4. If x is 2, solution will be 2, 0, 2, 1, and 2, 2. If the solution is 3, then if x is 3, the solution will be what? 3 and 0. And for x equals to 4, the value of y becomes negative and hence not valid. So when x becomes equals to 4, then our y values it changes to what? A negative number, and so it does not what valid, and it had them, so then it's not valid anymore. So this is a solution to present as follows. This solution, so that what we just solved is presented as follows below. So our y positive, negative, x positive, x negative, x positive. 8, 7, 6, 5, 4, 3, 2, 1, 1, 2, 3, 4. All these points are following these points here. That was one when x equals to, when 1 and 0, 1 and 1, 1 and 2, 1 and 3. It won't even come here, but we also continue, but I want to stress all those stuff. This is for 2 and 0, 3 and 0, 4 and 0, 5 and 0. So that's what odd lines here means. To 8. This is 2 and 1, 2 and 2. So this is 3 and 1. This is 4 and what? 4 and 1. So is this 1 and what? 1 and 4. That's what it is. 1 and 4 and 2 and 2. Then we plot our line. Then 4, then I want to put our initial equation, but in this form. You know, when in last I said when it is represented in this form, we change it to equal to and use a dark line to present it on our graph. This is what's happening here. So this is 40x plus 20y equals to 120. So the line comes through to the point, the major point. This is point P and point what? And point Q. This is the right side half plane. Half plane right, and the left half plane. So let's try to extend this solution to real numbers. For this, draw a graph of an equation 40x plus 20y equals to 120. Now let's consider a point 0, 0 and check if it satisfies the inequality we have. 40x plus 20y is less than what? 0. So let's say let's present what? Put y as 0, x as what? 0. So what we're getting what? 0. So now when we solve this into the whole equation, substituting the value of x and y, we get 40 times 0 plus 20 times 0 is less than what? 0. So now we have all 0 is less than what? 0. So this is the same thing as here, because 40 times 0 is 0, 20 plus 0 is 0, 0 plus 0 is what? Is 0. So having 0 is less than what? 0, which is true. Hence, we can conclude that the point 0, 0 satisfies what? Inequality. Look at the diagram below. Forget this line I cancelled. Look at the major line here. Came down. This is 1 to 4, 1 to 4, like a line, dotted line, dotted line, dotted line down here. And we have 2 to 2. This is 2, 2 to 2. That is what it is here. So the line crossed through these 2 points. Our left hand plane, our right hand plane. When everything is what? Equals to what? When 0 and 0. Then our dark line came again here. represent 40x plus 20y equals to 120. So in this graph, you can see that the point 0, 0 lies in the half plane 1, hence the inequality represents this plane. Also, the point on the line satisfies the inequality, hence it is also a part of the shaded word region. This part was shaded. This part was shaded. Example 2. Solve 3x plus 2y greater than 6 graphically in two-dimensional plane. This one in two-dimensional plane. Solution. To solve the inequality, let's plot a graph of the equation 3x plus 2y equals to 6. So now see the graph here. This is how the graph looks like here. 3x plus 2y equals to 6. So the graph will look like here. This is shaded region. Region 2 was shaded region. The half plane 2 was shaded region. This is the left and this is right. So proceed. This line divides the plane into half plane 1 and half plane 2. Next, we select a point 0 and 0 and determine if it satisfies the given inequality. Hence, we are here. 3x plus 2y is greater than 6. If you put 0 here, put 0 here, this becomes 0, it becomes 0. Greater than 6. So we are having 0 is greater than 6, which is false. So if you put 0, 0, it is false because 1 is still 6 and 1 is 0. So it is what? Which is what? A 4. So 0, 0 lies in the half plane 1 and it does not satisfy the inequality. Inequality. Half plane 1 is not the solution. Also, the inequality given a straight inequality. Hence, any point on the line presented by 3x plus 2y equals 0 does not satisfy the inequality. Therefore, solution of the inequality is shaded in this shaded region in the graph alone. The graph above. Sorry, I made a lot of mistakes today because my mind has not been in one place. I'm just thinking about what else to do now. This is one source of joy I had. Like every week, I'm set to come and do a class for you. It's all anyhow, but this is the end of the class. I wish you success in your exams. Our MCH 154, we're going to do it and it's going to be a blast. It's going to be a blast.